Hi everyone. So in this video, we're on page 224 in the binder, so it's kind of our second exponents video. Yesterday we talked about when you multiply powers together, you add the exponents. We also did a little exploration and found out that anything raised to the 0 power is 1. And so here we're going to start with a little warm-up at the top of the page. Okay, and what we'll see here, it says show the difference between 5x to the fourth and then parentheses 5x to the fourth. So in the first one, there's no parentheses. What that means is that the 4 is only attached to the x. So when I expand this one out, I get 5 times x times x times x times x, right? And the x is the only thing that's got repeated multiplication. There's only one 5, but there's 4 x's. On the other hand, when there's parentheses, it means the 5x is being raised to the fourth. So to expand that out, I have to do 5x times 5x 4 times. So I get 5x times 5x times 5x times 5x. Another way we could write that is 5 times 5 times 5 times 5 times x times x times x times x. Right? That's the repeated multiplication. And so what we see here is that when there's parentheses, both the 5 and the x are written 4 times. Okay, so let's try a couple down here. Expand the following powers by showing repeated multiplication, and then simplify if we can. So in A, we have 4 squared to the third. That means write 4 squared times itself 3 times. So we have 4 squared times 4 squared times 4 squared. Now, using the rule from the other day, we're multiplying powers together, so they have the same base, so I can add the exponents. 2 plus 2 plus 2 would be 6. So my answer there is 4 to the 6. If you have a calculator, we could figure out that this is 4,096. In B, for B, we have x to the fourth squared. That means I'm going to take x to the fourth times itself. X to the fourth times x to the fourth. And then what we do here is add those exponents because it's the same base. So we get x to the 8th. In part D, we have negative x squared. That means take negative x times itself. So it's negative x times negative x. Well, negative x times negative x times x is x squared. And you can think about those exponents are 1, so 1 plus 1 is 2. But negative times negative is positive. So my answer here is positive x squared. And part E, we have negative x to the third. So this is going to be negative x times negative x times negative x. And this time, and I get negative times negative times negative is really positive. Nope, that's wrong. Negative times negative times negative is negative. And then x times x times x is x to the third. So for a negative, we end up with, or to the third power, we just get negative x to the third. The parentheses kind of go away. But on part D, when it was negative x squared, the negative went away, because when you square a negative, it becomes positive. All right, what else do we have on this page? A little summary. So do you see any pattern here? Okay. Oh, we missed a couple problems. C and F. Part C. Let's go back. Hold on. So in part C, we have x to the 6th to the third. So I'm going to write x to the 6th times itself 3 times. And then I add those exponents, so you get x to the 6th, 12, 18th. All right, and then finally in F, 2x to the 4th. So that would be 2x. That would be 2x times 2x times 2x times 2x. And if we look at that, it's 2 times 2 times 2 times 2 times x times x times x times x. Right? Another way to write this would be 2 to the 4th, x to the 4th. Interesting. Okay, so let's see if we can find a pattern here. At the bottom, we have a little place to summarize. So hopefully you've seen the pattern. 4 to the second to the third ended up with 4 to the sixth. X to the fourth to the second ended up with x to the eighth. X to the sixth to the third ended up with x to the 18th. Well, the rule we did there is we multiplied the exponents. 2 times 3 was 6, 4 times 2 was 8, 6 times 3 was 18. Okay, so when raising a power or a product to an exponent, I can multiply the exponents. Okay, so the rule for a power of a power, okay, is a to the m to the n. I just multiply, so it becomes a to the m times n. That's like a, b, and c. All right, and then with d, e, and f, okay, what we're really doing is raising a power of a product. Okay, and so each of the pieces, and it's really f is the best example of this, each of the pieces gets the exponent. So it's a to the n, b to the n. So let's try a couple here. Now that we know this rule, it becomes a little faster problem. 2 to the 10th to the third, just multiply the exponents, because it's a power to an exponent. 2 to the 30th. In b, a to the 8th to the 6th, I can multiply the exponents. I get a to the 8 times 6 is 48. And then in c, b to the 12 times 5 would be b to the 60th. All right, let's check out the next page. There's a bunch of practice on this page. I'm going to pick and choose a few for us to do. Let's start with F. Okay. In problem F, we have negative ab to the third raised to the fourth power. Okay. One of the things to remember with this is that negative really represents negative 1. So I'm going to actually rewrite this. I'm going to say negative 1 times a times b to the third. Okay. So our power of a product rule tells me that I can give the 4 to all the pieces inside the parentheses. So this really becomes negative 1 to the fourth, a to the fourth, and b to the third to the fourth. Well, negative 1 to the fourth would be negative 1 times negative 1 times negative 1 times negative 1, or a negative to a positive number, or to an even number, becomes positive. So I get just 1. Negative 1 to the fourth is 1. A to the fourth is just a to the fourth. And then b to the third to the fourth, here's my other new rule, I multiply those exponents. So I get b to the 12th. So my final answer there is a to the fourth, b to the 12th. Okay. I showed a little bit more work than you probably would as you get better at these. When you see a negative to an even power, you just know it's going to be positive. Then you would say a to the fourth, you could go right to that, and b to the 12th, you could go right to that. So this is a problem. Eventually, you could get straight to this answer. Let's look at I, since I'm right here. In problem I, we have 2 to the 5th, c to the 4th, d to the 7th, all of that raised to the 3rd. Okay, so I'm going to use kind of both properties at the same time. I'm going to hand the exponent 3 out to all 3 factors, and then I'm going to use the power to power rule and multiply the exponents. So this becomes 2 to the 15th, c to the 12th, d to the 21st. 2 to the 15th you need a calculator for. All right, let's see what else we have. Look at H. In problem H, it's 7 to the 5th, g to the 9th, h to the 15th, all to the 0. So if you're paying attention, this one's a very fast problem because the answer is just 1. Anything to the 0 power is 1. All right, couple more. Let's look at K. Negative 3x squared, y to the 6th, z to the 9th, all to the 3rd power. Okay. So again, when you get a negative number here, I like to just separate that out. So this is going to be negative 3 to the 3rd, and then it's going to be x to the 6th, because I'm multiplying these exponents as I hand out the exponent to everything in the parentheses. Okay, so x to the 6th, y to the 18th, and z to the 27th. All right, so I'm raising a power to a power, so I'm multiplying the exponents. And then here, negative 3 to the 3rd, well, it's a negative to an odd power, so it's still going to stay negative. And then 3 to the 3rd is actually 27. 3 times 3 times 3. X to the 6th, y to the 18th, z to the 27th. All right, almost done here. With fractions, so now we're at the bottom of the page, example 3. With fractions, I've got 1/4 to the 3rd power, so let's find a couple patterns here. We have 1/4 times 1/4 times 1/4 would be 1/4 to the 3rd, which is 1/64. All right. And then if we do a couple more of these, let's try e. We'd have x over 5 times x over 5 times x over 5. That would be x cubed over 5 cubed, or x cubed over 125. Okay, so you should notice the rule is similar to the multiplication rule. The exponent is going to go to both the top and the bottom. So x over 5 to the 3rd becomes x to the 3rd over 5 to the 3rd. So let's flip the page and finish this video out. All right. So to write this rule here, let's do raising a fraction to an exponent. I can raise the top and bottom to that exponent. Raise top and bottom to that exponent. Okay, so that becomes a to the n over b to the n. All right, I know it's been a little longer, so I want to cut this video off here, but let's just do a couple examples. So part A to the 25th over b to the 25th. Very simple. In part B, c to the 6th over 8 to the 6th. You could figure the bottom out with a calculator. In C, I have PQ on top. So both P and Q get the exponent. So it's P to the 15th, Q to the 15th over W to the 15th. Let's pick one more to do here. How about F, just to finish it off. So in F, again, everything gets the exponent. So it's 2 to the 4th. E to the, I should multiply those. 3 times 4 is 12. And then F to the 2 times 4 is 8. Over G to the 11 times 4 is 44. Okay. So there's your answer there. 2 to the 4th is 16, so you could replace that there. All right, we'll practice this more tomorrow. Thanks for watching.